We've inserted ordinary level to circle exam questions. Question 2. Part A. S is the circle x squared plus y squared equals 25. Part 1. Write down the centre and radius of the circle S. So since this equation is in the form of x squared plus y squared, we know that the centre is 0, 0. So circle centre 0, 0 is always in the form of x squared plus y squared equals r squared. Whereas if it had said something here like bracket x minus 1 to be squared plus bracket y plus 5 to be squared, for example, we would know then that the centre was not 0, 0. So if it's in this form, x squared plus y squared equals r squared, we automatically know the centre is 0, 0. So if r squared is equal to 25, then r is equal to the square root of 25, which is 5. So the radius is 5 units. Part 2. Show that the point 3, minus 4 is on circle S. So we're going to write out our equation again. So x squared plus y squared equals 25. We're going to swap the x and y for empty brackets. We're going to label our point x and y. And then in place of the x, we put 3. And in place of the y, we put minus 4. Make sure you use brackets here or it will go wrong. Then 3 squared is 9. And minus 4 squared is positive 16, because minus 4 by minus 4 is plus 16, because a minus by minus is a plus. And then 9 plus 16 is 25. So since the equation balances, the point 3, minus 4 is on the circle. Another way of working it out is this method. So instead you could have said, well, the centre is 0, 0. We know that from the equation. And the point we're interested in is 3, minus 4. So if the distance from the centre to the point is equal to the radius, then the point is on the circle. So we're going to use our distance formula from page 18 of our formula book. So we're going to write that out. So we have the square root, bracket x2 minus x1 bracket squared, plus bracket y2 minus y1 squared. So I'm writing it out again, this time leaving space to sub in. So I have a space where the x2 was, the x1, the y2, and the y1. I then label my points x1, y1, x2, y2, and then I sub into my formula. So I replace the x2 with 3. I replace the x1 with 0. I replace the y2 with minus 4, and I replace the y1 with 0. You can put this straight into the calculator if you want, or work it out step by step. So bring down the square root, and 3 to be squared is 9, and minus 4 to be squared is positive 16. And then the square root of 9 plus 16 is 25. And then we have 5 units. The square root of 25 is 5 units. So since the distance between the points is equal to the radius, this proves that the point is on the circle. So part 1 and 2 is for 10 marks. Part 3, write down the coordinates of 2 other points that are also on circle S. So we know the centre is 0, 0. And we know there's a radius of 5 units. So you can draw a rough sketch of what that would look like. So here's my centre at 0, 0. And if there's a radius of 5 units, then the circle passes through 5 on the x-axis, minus 5 on the y-axis, minus 5 on the x-axis, and 5 on the y-axis. So 5, 0 is 1 point on my circle. So 5, 0. 0, 5 is another point. And we were only asked for 2, but I'll give you 2 more. Minus 5, 0. And 0, minus 5. So part 3 is worth 5 marks. B. Find the points of intersection between a different circle K and the line L, where L is 5x minus y minus 13 is equal to 0, and K is x squared plus y squared equals 13. So what we're trying to do here is solve simultaneously. Find x and find y. So we start off by writing out the simpler equation, so the one without the squared. So this is the line. So 5x minus y minus 13 is equal to 0. So you can either solve for x or solve for y, but you have to get one of them on its own. It's much easier to get the y on its own because the 5 is stuck onto the x. So we're going to solve for y. So we're going to bring the 5x and the minus 13 over the equal sign. So we get minus y is equal to minus 5x plus 13. Now we wanted to solve for y, not minus y. So in order to make this a positive, I'm going to multiply across by minus 1. And minus y times minus 1 is positive y. Minus 5x by minus 1 is 5x. And 13 by minus 1 is minus 13. So now we have y on its own. We're going to sub that into the circle equation, the bottom equation. So we're going to write out the bottom equation again. And in the next step, I'm going to swap the y for an empty set of brackets because I solved for y up here. So I'm going to swap this y for an empty set of brackets. And into the brackets, I'm going to put 5x minus 13. So this is the tricky bit, so just be very careful here. So 5x minus 13 goes into the brackets, and that is to be squared. Everything else remains the same. So I'm going to bring down the x squared and the plus, and then 5x minus 13 to be squared, I'm going to do rough work. So 5x minus 13 to be squared is 5x minus 13 multiplied by 5x minus 13, which gives me 5x times 5x minus 13 times 5x minus 13, which gives me 25x squared minus 65x plus 169, which gives me 25x squared minus 130x plus 169. So I write that down here. So I had equals 13. So now I need to solve. Ultimately, I'm trying to solve. So I'm going to try solve for x. Now, since I have squareds, I'm going to bring everything to the left or everything to the right. So most of the terms are already on the left, so it's much easier to just bring the 13 over to the left. And don't forget that x squared is really 1x squared. So 1x squared plus 25x squared is 26x squared. I'm going to bring down the minus 130x. I'm going to bring down the 169. And then the 13 will come over the equal sign and become minus 13. And that's equal to 0. So I'm going to keep simplifying as much as I can. Bring down the 26x squared. Bring down the minus 130x. And 169 minus 13 is 156. And that's all equal to 0. Now let's see, can I simplify even more? So is there a number that I can divide into all three terms? Well, I could divide 2 into all three terms, but I could actually divide 26. So if you didn't spot that you could divide 26 evenly into all three terms, start off with 2 and then keep dividing until you get your equation as simple as you can. So 26x squared divided by 26 is 1. So we've got 1x squared. Minus 130x divided by 26 is minus 5x. And 156 divided by 26 is 6. And that's equal to 0. So now I've got a quadratic trinomial. So I've got x squared minus 5x plus 6 is equal to 0. Remember, ultimately we're trying to solve, which means find x and find y. So to solve a quadratic trinomial, our options are factorize and solve, or use the minus b formula. So I'll show you both methods, but you only have to do one method, whichever suits you. So I'm going to solve x squared minus 5x plus 6 is equal to 0. So factorizing, I bring down the x squared, I bring down the plus 6, and I'm going to break the minus 5x into two parts. This plus here tells me that these signs will be the same. And then I look here to see that there's a minus, so they'll both be minus. So I've got minus something x minus something x. I get the factors of 6. They are 1 times 6 and 2 times 3. I need to choose a factor pair that's going to end up giving me minus 5x. So minus something has to give me minus 5. So 2 and 3. So it doesn't matter which way you arrange them because they're the same sign. But if you had a different example where one was a plus and one was a minus, you'd have to be very careful what way you arrange them. So I factorize the first two. So the highest common factor of x squared minus 2x is x. So x squared divided by x is x. And minus 2x divided by x is minus 2. So then I factorize the next two. So minus 3 is my highest common factor. Minus 3x divided by minus 3 is x. And 6 divided by minus 3 is minus 2. Notice that my brackets match. So x minus 2 is one part of my answer. And then x minus 3 is the other. Now, ultimately, I'm trying to find the points of intersection, which means I'm trying to solve. I have factorized, so in order to solve, I need to let this equal to 0. So if x minus 2 is equal to 0, then x is equal to positive 2. And if x minus 3 is equal to 0, then x is equal to positive 3. So now I've found my two solutions for x. I also need to find my y values, but before I do that, I'm going to solve using the minus b formula and show you that I'll get the same answers. So I write out my equation. I draw in my invisible 1. I label a, b, and c. I write out the minus b formula, which is x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. This is given to you in the formula book. You do not need to learn it off, but make sure that you do write it down because it's worth marks in an exam. I then write out the formula, but I swap every letter for empty brackets. The brackets are essential here or you will go wrong. So in place of the a's, I'm going to sub in 1. In place of the b's, I'm going to sub in minus 5. Careful here, now make sure you put in minus 5, not 5. And in place of the c, I'm going to put 6. Okay, so then I simplify. So minus 5 is positive 5. Then I have the plus minus. And then on the bottom, 2 times 1 is 2. And then inside the root, minus 5 squared is 25. And minus 4 times 1 times 6 is minus 24. And 25 minus 24 is 1. So I have 5 plus minus the square root of 1 all over 2. So the square root of 1 is 1. So I end up with 5 plus 1 over 2, or 5 minus 1 over 2. So 5 plus 1 is 6. So we get 6 over 2. And 5 minus 1 is 4, so we get 4 over 2. And then 6 over 2 is 3, so x is equal to 3. And 4 over 2 is 2, so x is equal to 2. So we get the same solutions for x as we did over here. So we were asked to find the points of intersection, and every point has an x and a y part. So we've got our x values, now we need to find our y values. So we know x is equal to 2 and x is equal to 3. Now find y. So I'm going to write down the linear equation, which is the simpler equation, which is 5x minus y minus 13 is equal to 0. I'm going to swap the x for a set of brackets because we know what x is. And into the brackets, I'm going to put 2. 5 times 2 is 10. Bring down the minus y, the minus 13, the equals and 0. Now I'm trying to find the points of intersection, so I have to solve for y, get y on its own. So I'm going to bring the 10 and the minus 13 over the equal sign. So I'll have minus y equals minus 10 plus 13. Now I want to solve for y, not minus y. So I'm going to have to change the sign. So minus 10 plus 13 is 3. And then multiplying across by minus 1, I get y is equal to minus 3. So I was asked to find the points of intersection. So one of them is x, my x value is 2, my y value is -3, so 2 comma -3 is one of my points of intersection. I then do the same with x is equal to 3. So I write out my linear equation again from up here, 5x minus y minus 13 is equal to 0. Again, I swap the x for empty brackets, and into the brackets this time I put 3. 5 times 3 is 15. I bring everything else down, and I want to solve for y, get y in its own. So the 15 and the minus 13 come over the equal sign and change sign. Minus 15 plus 13 is -2. And then I multiply across by -1 to make the y positive. So I get y is equal to 2. So I was asked for the points of intersection. So my second point of intersection is 3, 2. And if I draw out my circle, which you weren't asked to do, but I generated this using the GeoGebra website. So there's the line in purple. That's the line 5x minus y minus 13 is equal to 0. And the red circle is the circle x squared plus y squared is equal to 13. And we can see that the points of intersection are indeed 3, 2 and 2, -3. So this part B is for 15 marks.